Hello. In this video, I want to look at trying to solve a practical application using the equation for a parabola. And in this question, we're given that there's a parabolic bridge and it has an arch. And basically, you have that it has this definition that we see in this diagram over here that has a span of 120 feet and it has a maximum height of 25 feet. So what I have here is an equation already highlighted or presented in the format of a vertical parabola that is going to open either upward or downward in any case. Now, here, what we could probably do is say that, for instance, we know that the maximum height of this equation is given to be 25 feet. But we could probably instead say that, for example, that h is going to be the center, so that's going to be x equals to 0, or h equals to 0. So that's what we're saying here. H equals 0, and that k will equal to 25. So our goal is to essentially just come up with the equation from there, because we know that, yeah, that x squared is equal to 4p times y minus 25. Now, the other thing of which that we do know is that if there's a span of 120 feet, that means that we could probably just say that, if we have that the span is 120 feet, then we have that one of the ordered pairs that we could work with, for example, could be 60 and then comma 0. But then for that matter, we could probably also use negative 60. And in that case, that would have to be 0. Okay. So here, what I can do is just say that, well, okay, so if I'm going to plug in, 60, then the y has to be 0. Okay, so that's going to be 60 squared equals to 4p times, well, in this case, we have that it's 0 minus 25. And notice this, we can just solve for 4p. Why not? Because 4p is what we have in the equation. So that means that 4p equals to basically 60 squared, and that's divided by negative 25. Now, notice that that presents the equation in a different light, because now that says that the equation is going to be x squared equals to, well, that's going to be negative 60 squared divided by 25, and this is going to be multiplied by y minus 25. Now, notice that in this case, if we're trying to find specific heights, then we only need to look at how far we will go out. Like, for example, if we go out 10 feet, 30 feet, 50 feet, and that's from the center. So for that, we have to substitute x, basically. Now, notice this, though. If we solve for y is going to equal to, well, it's going to equal to negative 25 divided by 60 squared, and that's multiplied by x squared, and then plus 25. Now that's kind of interesting because it's telling us that the equation that defines the height of the arches, that it's going to be defined by this equation that we have right here. So ideally, if we go ahead and we substitute whatever x is in this case, then all we have to do is just substitute it. So that's going to be, like, for example, we have x equals to 10. So that tells us that the y variable, or the height of the equation, is going to be negative 25 divided by 60 squared multiplied by 10 squared, and that's going to be plus 25. Okay, so here, let's do that computation, right? So here we can probably just compute 25 divided by 60 squared. And in this case, we know that it's going to be negative. So that's going to be multiplied by 10 squared, and then plus 25. Now, notice that that's telling you that the answer to this equation is 24.3 feet. So we have that if we go out 10 feet, that the height of it is going to be 24.3. So, we can say that basically that we have the solution, that, that so that's going to be at 10 feet from the center, we have that the height will be 24.3 feet. Now, interestingly enough, though, if we were to plug this into, let's say, for example, Desmos, then basically we could probably essentially figure out the height from there respectively. So imagine if we had already found basically the height of our bridge using that same model, then in that case we can just plug it in. So negative 25 divided by 60, and we said that it's squared, and then that's going to be x, but it's going to be plus 25. Now, of course, let's see, let's give this some different parameters. So I'm going to do negative 75 to 75 because that's how we sort of defined it. The y-axis, for whatever reason, it's pretty high. So maybe like -1, and then we can probably just say that this is going to be 50. Let's see. Oh, and I forgot to square that. Okay, so we're going to square that. And okay, there's our nice parabola. Okay, so we have this nice parabola that defines the arch, essentially. And note that, we said x equals to 10, right? Okay, so here we get that it's 24.3 feet. And of course, similarly, it was x equals to 30, right? That's what they wanted us to find. So we see that that's 18.75 feet. Now, keep in mind that they wanted to find at 50, right? Okay, so actually, why don't I just do this? Well, let's say that x equals 50. Okay, so x equals 50, and we have that we're now at 7.63, 7.6 feet, right? Now, in either case, well, the sentiment that I have towards this type of example is that I'd like to ask myself, did I really need this particular model? So like x minus h squared equals 4p times y minus k. Did I really need this particular model? And truthfully, the answer is no, because basically we could have directly just said that, well, if we know that the equation of a quadratic function is given by y equals to a times x minus h squared plus k, then in that case I can just model it that way, and it becomes a lot easier because you saw that I had to solve for 4p first, then I had to plug it back in, then I had to plug in the x equals to 10, 30, and then 50 respectively. So notice that if you would have chosen that y equals, and it's centered at the origin with the maximum height of 25, then look at this. You're automatically going directly to ax squared, and then that's plus 25. At that point, the rest is just you substituting the value of x equals to either 60 or negative 60 respectively. And then from there, you'll just go ahead and solve for when it's 10 feet, 30, and 50 in either case. But notice that you could also make it more complex, if that makes sense, because you could have centered the origin as the highest. But then at that point, now it's like you're saying that you have to go down 25 feet in actuality. And that's where it can get kind of tricky, if that makes sense, that you would have to say that, well, if the vertex is at 0, 0, then that means that the ordered pair is no longer 60, 0, but 60, negative 25. And that's kind of interesting. And that kind of deviates from this model that I have highlighted here. But either way, you see that the math works out regardless. And it's more or less just a matter of preference as to how would you like to determine the height at a particular function or at a particular spot in any case. Like if we're finding the height of something that's parabolic. Similarly, you'll see the same thing in your other conic sections in terms of the hyperbola, the ellipse, and so on.